Here in this video, we are solving a problem basing on heat engine. Let us see what's the data given in the problem. It is given that the source of the heat is at 127, who has an efficiency of 70%. Let us stop there for a minute and write the equation for the efficiency of heat engine. Efficiency of heat engine can be defined as the part of the work done when compared with the heat energy supplied. I'm just going to the basics itself. In heat engine you have source, working substance, and sink. From the source you supply some heat energy, it do some external work, and the remaining heat is rejected to that of the sink. As for the conservation of energy, total heat from the source can be written like work done plus heat energy rejected to the sink. So dW can be written like dQ1 minus dQ2. Efficiency, as I have said, work done, that is dQ1 minus dQ2 by heat supplied is dQ1. That is 1 minus dQ2 by dQ1. As temperature is proportional to energy, I can write a formula for the efficiency as 1 minus T2 by T1, where T2 is the temperature of sink, T1 is the temperature of source. After knowing these basics, I can go to the problem. Efficiency is given as 1 minus T2 by T1. Efficiency is given as 70%, that is 0.7. 70% means 70 by 100, that is 0.7. 1 minus temperature of the sink is not given for you, but temperature of the source is given as 127 degrees centigrade. Be careful. I have to write it in Kelvin by adding 273. So 1 minus T2 by 400 equal to 0.7. So T2 by 400 equal to 1 minus 0.7, that is 0.3. So T2 equal to 400 into 0.3, that is 120 Kelvin. Be careful, you get it in Kelvin. That's the temperature of sink. That's the question itself. What is the temperature of the sink is? So I have calculated the first part of the problem. Now we have to go to the second part of the problem. What is that second part of the problem says is, keeping the temperature of the sink same. That means in this problem also, temperature of the sink is what you got in the previous case, 120 Kelvin. Now the problem is by how much the source temperature has to be increased so that it will have a new efficiency of 90%. So if you write now efficiency formula, efficiency dash I will call 1 minus T2 by temperature of source. New efficiency as per the problem is 90%. 1 minus temperature of the sink is kept same like a previous case. By what is the temperature of the source is the question itself. 90% means 90 by 100, that is 0.9. That is 0.9 equal to 1 minus 120 by temperature of source. So 120 by temperature of the source is 1 minus 0.9, that is 0.1. So temperature of the source is 120 by 0.1, that is 1200 Kelvin. Be careful, what I get it is in obviously Kelvin. What I get it is obviously in Kelvin. Once you know, after getting the temperature of the source, now go to the question once again carefully and see. By how much temperature of the source has to be increased? What is the earlier temperature of the source, like we have calculated? That is 127 centigrade, or 127 plus 273, 200 Kelvin, right? So taking that into consideration, temperature of the source in first case is 127 degrees centigrade, add 273, so it becomes a 400 Kelvin. New temperature of the source to get an efficiency of 90% is 1200 Kelvin. That implies rise in temperature of source is finally 1200, initially 400, that is 800 Kelvin. So you shall raise the temperature by 800 Kelvin so that you will get what is all is being asked to find out. That's how we solve the problem. Thank you for watching.